Hey everyone, welcome to Aionlinecourse. In this tutorial, we'll introduce the voice cloning application using RVC project. Voice cloning is transforming AI and speech technology. Whether you're a developer or just interested in AI, this project will teach you how to create high-quality voice clones with ease using advanced RVC techniques and generate realistic voice clones. We'll do everything in Google Colab, so you won't need to install anything on your computer. We'll follow a simple 5-step process to build the project. Step 1. Environment setup and resources. We'll set up Google Colab, connect Google Drive, and install the necessary tools and pre-train models. Step 2. Audio preprocessing and cleaning. We'll clean and prepare audio using libraries like Librosa and PyDub for better model input. Step 3. Model selection and training. We'll choose an RVC model and train it using the prepared audio data. Step 4. Voice tuning and transformation. Here, we'll adjust pitch and tone and apply gender-based voice conversions. Step 5. Evaluation and monitoring. Finally, we'll evaluate the output quality, test the cloned voices, and monitor model performance. Before we start coding, head over to Google and search for voice cloning application using RVC.Aionlinecourse.com. You can dive into this complete voice conversion project at Aionlinecourse.com, where we break down each step with clear, easy-to-follow instructions. The site offers practical insights into the voice conversion process, along with full source code to help you learn by doing. Whether you're just starting out or looking to sharpen your skills, the detailed tutorials and code samples are designed to guide you through building and training your own AI-powered voice models. Now, let's jump into the actual code demo on Google Colab and see how everything we just talked about works in practice. First, mount Google Drive in the Colab environment at Content Drive, allowing you to access and save files between Colab and Drive. Next, the input form gathers settings that allow users to select the processing mode and audio source, either YouTube or Google Drive, while also defining the name for the audio dataset to be handled. After that, it installs the required libraries YTDLP and FFmpeg and creates a folder YouTube only if the selected dataset source is YouTube. Otherwise, it skips the setup when the source is Drive. Next, downloads audio from a YouTube video using YTDLP, converts it to WAV format with FFmpeg, and saves it in a YouTube folder. The process runs only if YouTube is selected as the dataset source. The audio file name is based on audio name, and the process is wrapped in a function that takes the YouTube URL as input. After that, it installs or updates the demux library, which is used for separating audio into different sources using Python's pip package manager. Next, separates vocals from audio using demux, based on the dataset source Drive or YouTube, by setting the input path accordingly, running the demux command to split vocals from other elements, and printing the result. Now, copies separated audio files to Google Drive by creating a folder named after audio name, placing the demux outputs inside, and adding the original WAV file if the source is YouTube. After that, we prepare to split audio into smaller chunks for training. If the mode is set to separate, the step is skipped. If set to splitting, it installs the required audio libraries NumPy, Librosa, and SoundFile, and creates a dataset folder named after audio name to store the split files. Now, we slice the vocal audio into smaller chunks by detecting silent regions using root mean square energy. It loads the vocals extracted by demux, then uses a custom slicer class to find and split the audio at silent intervals based on configurable parameters. If the mode is set to splitting, it processes the audio and saves each chunk as a separate .wav file in a dataset folder named after audio name. If the mode is separate, it skips this step. If the mode is splitting, it creates a folder in Google Drive and copies the split audio files there. If the mode is separate, it skips this process. Now, it removes a file from Google Drive, clones a GitHub repository, and moves the repository to a new directory. Now, install Aria 2, a lightweight multi-protocol and multi-source command line download utility, on the system using apt, a package manager for Debian-based systems. After that, download multiple pre-trained voice conversion models from Hugging Face using Aria 2 and store them in specific directories. Now we download Hubert-based.pt and RMVP PT pre-trained models from Hugging Face and store them in designated directories. After that, it compresses the QQ folder and saves the zip file to your Google Drive. Sets or switches the default Python 3 version if multiple are installed. Now, unzips the QQ project from Google Drive to the working directory, navigates into it, updates pip, and installs the required Python dependencies. After that, set up the training configuration by defining parameters like model name, dataset path, sample rate, and version. It then creates the necessary folder structure and log files under the QQ logs model name directory to store preprocessing and feature extraction logs. We preprocess the dataset by calling preprocess.py, which extracts and prepares features using the dataset path, sample rate, and output folder, essential for training. After that, it patches PyTorch's torch.load function to always load full model checkpoints by setting weights only equals false. This ensures compatibility during training or inference when complete model data is required. Now, for feature extraction, we extract F0 pitch features from audio using either a standard or GPU-accelerated method, depending on the selected F0 method. Then it extracts deep speech features from audio using the specified GPU CUDA 0, version v1 or v2, and experiment directory, enabling downstream training in the voice conversion pipeline. Installs FAISS for CPU and GPU to enable efficient similarity search, depending on available hardware. Next, the script loads .npy feature files from a directory based on the experiment ID and model version, concatenates them, and applies k-means clustering if the dataset is large over 200,000 samples. The processed features are saved as total FIA.npy for later inference, and if clustering is applied, the trained model is saved as k-means model.joblib. Throughout, it provides progress updates and error messages for transparency. Now, the Epic Recorder class records the time between successive calls to record, formatting the elapsed time and current timestamp for logging or monitoring purposes. Now, train the model. We prepare and launches the training process for a voice conversion model. It first gathers all necessary data paths, including ground truth waveforms, features, and optionally pitch features, then constructs a training file list combining them. It selects the appropriate configuration based on the model version and sample rate, and copies the config file to the experiment directory. Pre-trained models are optionally included, and mute samples are added for regularization. The script constructs and runs a command to train the model using a subprocess, streaming training logs to the console. At the end, the model and configuration files are saved in a dedicated experiment directory for later inference or continued training. After the R, copies the training output's model weights, index, and feature files to Google Drive and zips them for easy access or download. Finally, the script runs voice conversion using a trained model, processes the input audio with RMVP, saves the output, and plays the converted audio using IPython. First playing the input audio.
Would you like help downloading?
Then playing the converted audio.
Would you like help downloading?
This project lets you change voices using AI. It's useful for fun, dubbing, or creating unique characters. That's all for today's video. Thank you for watching. If you liked this project, don't forget to hit the like button and subscribe for more tech tutorials. Check out our next video on object detection with Yolov 8, link in the description. See you in the next one.